Let us now solve question number 42. The question number 42 says, a metallic right circular cone 20 centimeter high and whose vertical angle is 60 degree. So you might have studied about vertical angle in your class 9. What is the vertical angle? The vertical angle is the angle at the top of a cone, okay, the apex of the cone, the angle, the span of that cone means its vertical angle, okay. So the vertical angle of a metallic right circular cone is 60 degrees, is cut into two parts at the middle of its height, okay, by a plane parallel to its base. If the frustum so obtained be drawn into a wire of diameter 1/16 centimeters, find the length of the wire. Okay, so try to understand this concept. This question is very interesting. What it says, that I have a metallic right circular cone whose height is given as 20 centimeters, which is normal thing, but the extra information that is given is vertical angle. The vertical angle means the span of the right circular cone, okay. More the vertical angle means more the span of a right circular cone, and less the vertical angle means less span of a right circular cone. Let us see how in the diagram we can represent the vertical angle. For that, let us draw a right circular cone first. Now this is a right circular cone. Is it a right circular? No, it may not look like a right circular. Let me draw a base first and then it would be easy to draw. This is the base of a right circular cone. This is somewhere the center is, and I will draw a perpendicular to this center like this. Like this is the perpendicular, and I can see this becomes a right circular cone. Okay, this becomes a right circular cone. This represents the radius. This is the radius r. Okay, let us say r is the radius of this right circular cone, and the height of this cone is given as, height means the distance from apex to the base of this cone is 20 centimeters. Okay, this is the height of the cone and its vertical angle. Now let us understand the vertical angle. Vertical angle means the span of this cone. It means vertical angle is simply this angle. Okay. So what is vertical angle? If I project this cone on a plane, how to project a cone on a plane? Let us say if I have a cone like this. Let us assume that this is a cone, okay, and it's actually a cone. So if I want to project this cone on this board, what I will do is I will simply take a torch light and keep it here like this, such that light is focusing on this cone like this, and when I on the torch light, there will be a shadow of this cone on this board, and I will say this represents the projection of this cone. Okay, this represents the projection of this cone. If I have a torch light here, it will focus like this, the light will come like this, and I have a shadow of this cone. So that will be known as the projection of this cone, and the angle, this top angle that this projection has, will be known as the vertical angle. Okay, so if I project this cone, this will be the triangle. It will look like a triangle in the projection. Okay, if you see a cone in the 2 dimension, you can see it is basically a triangle. So how a cone is formed? If I have a triangle and I revolve, if I start rotating this triangle like this, then it will become a cone. So definitely if I project this cone on the board, the projection will be a triangle, and this angle of triangle, the angle at the apex, will be known as the vertical angle of this cone. Okay, so this is the general concept of vertical angle. Although this is not very much important, but still we need to know what is the vertical angle, how the vertical angle is known to us. So similarly, I can say this angle, this span of cone represents the vertical angle. Now the concept is that this axis, this line is what? This is axis of this cone. Why I am calling this axis? Because axis is a line which divides the cone in equal parts. Okay, or axis is a line which joins the apex of the cone to the base of its center. Okay, sorry, so center of its base will be the line which is known as apex, axis. So the concept says that this line, this axis, divides this vertical angle into two equal parts. Okay, or in mathematical term I will say this axis behaves as the angle bisector of this vertical angle. Okay, so let us write this concept. Axis is the angle bisector. Axis behaves as the angle bisector of vertical angle. Okay, it behaves as the angle bisector of this vertical angle. So definitely, if this complete angle is 60 degrees, then I will say that this angle is 30 degrees as well as this angle is 30 degrees. Both the angles will be 30 degrees, and we have the height as 20 centimeters. Now it says that this cone, if this cone is cut into two equal parts at the middle of its height. Now if I am cutting this cone at the middle of its height, it means the middle of its height means at the midpoint of this line. Midpoint of this line means, let us say this point is A, this point is, let us say, B, and this point is O. So B is in the middle of AO. It means AB is 10 centimeter as well as OB is 10 centimeters. So I am cutting the cone from this line like this. So this line, this length is 10 centimeter as well as this length is 10 centimeters. Okay, both the lengths are simply 10 centimeters. Now since I am cutting this cone from this line, like this plane which is cutting the cone is parallel to the base, because it is given in the question. The cone is cut into two equal parts at the middle of its height by a plane parallel to its base. Okay, this plane is parallel to the base. So the new figure formed is a frustum, which is like this. If I join this, this is the top of the frustum and this represents the frustum. This is the frustum that I have. Okay, so this is a frustum. Now I have this frustum. What it says further is, if the frustum so obtained, so we have got this frustum, and if this frustum so obtained is drawn into a wire of diameter 1/16 centimeters. So try to understand what exactly I am doing. I am changing this frustum into a wire. It means I am converting this frustum into a wire. So this is a concept of conversion of solids which is included in the frustum. So this is a hybrid question which includes the concept of conversion of solids as well as the concept of frustum. So what is the concept? The concept simply says, since this frustum is drawn into a wire, I can say this is converted into the wire. So what should remain constant? In the case of conversion of solids, we have discussed that volume of frustum will be equal to the volume of wire. This is the condition for the conversion of solids. This is what we have studied in conversion. So it means if I know the volume of frustum, I can calculate the volume of wire as well. And since the diameter of wire is given, I can calculate the length of the wire, because wire is basically a cylindrical solid figure. Okay, because this is the wire. So the diameter of the wire, it is given as 1/16 centimeters. Okay, so the radius will be half of this diameter. Now it means my task is to calculate the volume of frustum. Now what is the volume of frustum? It is 1/3 pi h to the bracket r1 square plus r1 r2 plus r2 square. So it means to calculate the volume of frustum, I need to know what is h, what is r1, what is r2. Do I have the height of frustum? Yes, definitely, because total height is 20 and this plane of cut is in the middle of the height. That's why the height of frustum is 10 centimeters. So I have the height of frustum. So height of frustum that I have is 10 centimeters. Now then R1 and R2, let us say this is R1 and let us say this is R2. So do I have the value of R1 and R2? No. Currently I do not have the value of R1 and R2, so I need to calculate the value of R1 and R2. Now let us think how to calculate the value of R1 and R2. Do I have used the each and every condition given in this question? No, I haven't used. The condition that is left to be used is this condition of vertical angle. Okay, I can mark, if this is B point, I can let us say mark this point as C and mark this point as D. So what I can see is ABC is a right angled triangle with AB as known, this angle as 30 and this BC is unknown, and BC represents the radius R2. In triangle AOD also is a right angled triangle. This AO, we know the value of AO but we do not know the value of OD, and this angle is given as 30. So consider first triangle ABC. This is the triangle ABC. In this triangle, this is the point A, this is the point B, this is the point C. This angle is 30 degree. This AB is given as 10 centimeters. So if AB is 10 centimeter, can I calculate the length of BC? Yes, you know trigonometry. You might have studied, no, not might have, you have studied trigonometry. So in this triangle, with respect to this 30 degree, this BC represents the perpendicular and this AB represents the base. So my task is to calculate a BC and I know the base. So to calculate perpendicular and I have base and this angle, so definitely I will use the trigonometric ratio which relates base and perpendicular. What kind of ratio do we have? We have the tan ratio, tangent ratio. So tan of angle 30 degree is equals to BC, that is perpendicular, upon AB as base. So BC is equals to tan 30 into AB. AB is 10 and and tan 30 degree is 1/√3. So the length of BC is 10/√3 centimeters. This condition I have. Okay. Secondly, consider the triangle AOD. This is the triangle AOD. This is A, this is O and this is D. So in this triangle AOD, what is AO? AO is 20 centimeter. This angle is 30 degree given, and my task is to calculate OD, that is the radius. Here this BC is 10/√3 centimeter, it is the radius R2. So to calculate OD, again I can see with respect to this angle, this is perpendicular and this is the base. So again I am going to use tan of 30 degree. because tan is the ratio which relates, tan is the trigonometric ratio which relates perpendicular and base. So tan 30 degree is OD divided by AO. So from this I will get OD is equals to, AO is 20 and this is tan 30 which is 1 upon root 3. So this will give you 20 upon root 3 centimeters. So this is the length of OD. I have OD, I have BC. Now can I calculate the volume of frustum? Yes. And volume of frustum is equivalent to the volume of wire. Now since this wire is a cylindrical figure, so let us say the L represents the length of this wire. Let us say L represents the length of this wire and the radius of this wire will be half of its diameter. So radius will be 1 upon 32 centimeters. So what should be the volume of this wire? Volume of wire will be pi r square h. Okay. So this is pi r square h. So what I am going to do is I am going to simply use this equation. This equation, that is volume of frustum is equals to volume of wire. Now volume of frustum, in place of volume of frustum I will write 1 upon 3 pi h r1 square plus r1 r2 plus r2 square is equals to volume of wire, that is pi r square L. Okay. Why I have written L? L is the length, okay, length or the height of the cylinder. So by solving this, this pi and this pi will get cancelled, and anything else to cancel? No. Now height of frustum is 20 upon 3. To the bracket, what is R1? R1 is this one, OD. So in place of OD, it is 20 upon root 3. So square of 20 upon root 3. Root 3 square. Plus R1 is 20 upon root 3. R2 is 10 upon root 3. Plus R2 is 10 upon root 3 square. So this is equals to radius of this cylinder. Radius of this wire is 1 upon 32 square into L, which is unknown. So further solving this, this will give you 20 upon root 3 to the bracket 400 by 3 plus 20 into 10 is 200 by 3 plus 10 square is 100 by root 3 square is 3. This is equals to 1 upon 32 square into L. So this implies 20 by 3 into, this will be 600 plus 100 is 700 upon 3, okay, and is equals to 1 upon square of 32 into L. So from this, L is simply equal to, I will bring that 32 here, so it will be 1400 14,000 upon 9 into square of 32. Okay, I will bring this volume, I will bring this 32 square here, and it will become L is equals to 14,000 upon 9 into square of 32. So this is the length in centimeters. So this is how you need to calculate the length of the wire. We have used the concept of conversion of solids. Okay, a very interesting question, very important question. So you can note this question. We have completed question number 42. There is a one mistake. Let me correct myself. What I did is I wrote this 20 this h as 20, that is height of frustum, but this h is basically the height of frustum. So by mistake I have taken it as 20, but actually the height of frustum is only 10 centimeter. So there is a small correction here. In place of 20 I will write 10. In place of 20 also again I will write 10. Here it will be 10, and this will become 7,000. Okay. So this is how you need to solve this question. I wrote it by mistake h as 20, but this h represents the height of frustum. What I did is I write this h as 20, but 20 is basically the height of cone. Okay, so just correct this and solve this, you will get your final answer. Okay.